Welcome back to part 2 of this series where we learn how to find the area using the midpoint rule. We ended off with question number 2, which reads, use the midpoint rule with n is equal to 5 to approximate the integral between the bounds 2 and 1 for the equation 1 over x dx. The graph of this equation is also shown on the screen, and we have the bounds 2 and 1. So our b value is 2 and our a value is 1. We can find delta x by substituting those 2 minus 1 over n, and they have 5 rectangles here, so I'm just going to choose an n value of 5 just to be consistent. 2 minus 1 is 1 over 5 is a fifth. So delta x is a fifth, and what this means is that each of our rectangles will have a width of 0.2. That's equal to 0.2. So starting at 1, we'll have a point right there at 1.2, a point right there at 1.4, the next one is 1.6, and the last one is 1.8. The average between 1.2 and 1, you can use your calculator. 1.2 plus 1 divided by 2 is 1.1. And you don't need a calculator for this. I just showed you that for clarity's sake. So that's 1.1. And unlike in question number 1, we don't have a table. So we'll use our equation to actually find what y is at 1.1. So 1 over 1.1 is 0.90 repeating. Let's start to build our equation for the area. Area is approximately equal to delta x, which we found to be 1 over 5, multiply to the y right there, and we found that as 0.90 repeating. Let's do the same thing for in between 1.2 and 1.4. The average is 1.3, so 1 over, that is equal to approximately 0.769. 0.769. We have to do this 3 more times. Now we have 1 over 1.5. That's 0.66 plus, again, 1.7, 0.588, and finally, one last one at 1.9. And that's 0.526. So I'll add this to the other numbers and multiply that by the factor on the outside, a fifth, 1 over 5, and we get the area as 0.691, or approximately that. 0.69 units squared. And there you have it. 2 examples on how to use the midpoint rule to approximate the area.